Hello everybody, welcome into another lesson. So today we are going to continue on with our unit on right triangles, and we are going to talk about Pythagorean Theorem, which by now I'm sure most of you are familiar with Pythagorean Theorem, but I do have to reiterate it and reteach it. Pythagorean Theorem states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. So here you have a triangle. The hypotenuse has a length c, and then the two legs have lengths a and b. So in other words, a squared plus b squared equals c squared. I know probably most, if not all of you, have seen that before. A squared plus b squared equals c squared. So let's get into some examples here. Alright, let's see what's up first. Alright, so let's see. This left leg has a length of 3. The base, this leg here, has a length of 4. And then the hypotenuse has a length of x. We want to solve for x. So how are we going to do that? Well, if we remember that c squared, which is x in this case, so that'd be x squared, is equal to each leg to the second power added to each other. So x squared equals 3 squared plus 4 squared, which would then, of course, give you 9 plus 16, which would give you 25. So we have the value of x squared is equal to 25. Now we just got to take the square root of both sides, and since this is a length, we're only going to consider the positive square root, because there's really no such thing as a negative length. So the positive square root of 25 is going to be 5. So the length of the hypotenuse with length x is equal to 5. All right. What does the next one look like? Interesting. There's another right triangle. We'll have this one here, of course. This leg will have length 12. This leg has length 5. And then the hypotenuse has length x. So again, we're going to solve for x. Well, we know the length of the hypotenuse to the second power, which would be x squared, is equal to the first leg 5 squared plus the second leg to the second power 12 squared, which would end up then giving you 25 plus 144, which then means that x squared equals 169. Well, now we just need to find plain old x. Well, of course, since it's a length, we're only considering the positive square root. So the positive square root of 169 would be 13. So the length of the hypotenuse with length x is 13. So Pythagorean theorem is relatively easy. It's really not a hard one. Alright, another twist here. Kind of tilted a little bit again. Let's see what we got here. We have another right triangle. And then, of course, okay, a little bit different here. This leg has length 6. This time the hypotenuse has length 10. This leg has a length of x. We still want to solve for x. but it's going to be a little bit different. So what do we know here? Of course, that a squared plus b squared equals c squared. So we'll take the length x, we'll raise that to the second power. You'll have x squared plus that 6 to the second power. That's going to be equal to the length of the hypotenuse to the second power, which would be 10 to the second power. And then, of course, we'll simplify this. You'll have x squared plus 36 would be equal to 100, which would then give you that x squared is equal to 64. And the positive square root of 64 is 8. So the length of that leg with length x would give you 8. So yes, Pythagorean theorem is very useful for finding lengths of right triangles that you're missing. All right, next. All right, let's put our right angle where it goes. X, 9, and 11. Okay. So this time we have a right triangle with one leg of length 9. The other leg has a length x. The hypotenuse has a length of 11. So, of course, we'll take the sum of the two legs raised to the second power, which would be x to the second power, plus that 9 to the second power. We'll set that equal to the length of the hypotenuse to the second power, which would be 11 to the second power, which now will give you x squared plus 81 is equal to 121, which then, of course, would end up giving you x squared equals 40. Well, we only consider, of course, the positive square root. So x would equal the square root of 40, but we know the square root of 40 simplifies, right? We always want to have a radical expression in its simplest form. So x can be simplified into the square root of 4 times the square root of 10. The square root of 10 doesn't break down any further, but the square root of 4 sure does. X would have a length of 2 times the square root of 10. And it is okay, unless they tell you to convert to a decimal and round your answer to the nearest 2 or 3 decimal places, for example, you can leave your answer with a radical in simplified form. So x has a length of 2 times the square root of 10. All right. In fact, 2 lessons from now, they're going to be heavily radical intensive. You'll see why. We're going to talk about special right triangles 2 lessons from now. Oh, whoops, I almost tripped. Not a good thing. Okay, so here we have that. We have a length of 10 on the shorter leg, a length of x on the longer leg, and a length of 20 on the hypotenuse. So, of course, once again, we're going to solve for x. So you take the length of this leg being x, raise that to the second power, plus you'll take the length of this leg, which would be 10, raise that to the second power, set that equal to the length of the hypotenuse, which would be 20, and raise that to the second power, which would simplify into x squared plus 100 equals 400, which would then give you that x squared equals 300. And now, of course, we want to take the square root of both sides, only the positive square root. X initially equals the square root of 300, which would simplify here. We can break this down into x equals the square root of 25 times the square root of 12, which would simplify further into the square root of 25 times the square root of 4 times the square root of 3. Well, the square root of 3 sure doesn't break down, but 25 and 4 do. X would equal then 5 times 2 times the square root of 3, which would then have to mean that x has a length of 10 times the square root of 3. So the length for x for this leg would be 10 times the square root of 3. Okay, what's next here? Here's another right triangle. Let's see what lengths we're given this time. A length of 12 here for the hypotenuse, a length of 8 for this leg, and a length of x for this leg. Of course, we're going to solve for x again, so take x squared. I want to write with blue. There we go. So take x squared plus your 8 squared. You'll set that equal to 12 squared, which would simplify into x squared plus 64 equals 144, which would then give you that x squared equals 80, which then, of course, x would become the square root of 80, but we have to put the radical expression in simplest form. Well, 16 and 5 are factors of 80, where 16 at least is a perfect square, so x would equal the square root of 16 times the square root of 5. 5 don't break down any further, but 16 does, so x would have a length equal to 4 times the square root of 5. So the value of x for this leg is 4 times the square root of 5. Oh yeah, some good ones here. Another right triangle. This leg here has a length of 4. Now this leg here has a length of 4 times the square root of 3. This leg here has a length of x. I think I already know the answer, but we're going to work it out with Pythagorean Theorem anyway. 2 lessons from now we will learn a shortcut about it, but I don't want to teach that just yet. So of course, take the length of your 2 legs squared. You would take, of course, the 4 to the second power plus the quantity of 4 times the square root of 3 to the second power. You would set that equal, of course, to x to the second power, which would then give you that x squared is equal to 16, plus in your parentheses you would have 16 times 3. If you take, of course, 4 times the square root of 3 to the second power, which then means that x squared is equal to 16 plus 48, which would then give you that x squared is equal to 64. And we know the positive square root of 64 is 8. So x, therefore, equals 8. think I already know the answer to this one also, but I'm not going to teach the shortcut in this lesson. I'll teach that in 2 lessons from now. Alright, this has a length of 6, this has a length of x, and this has a length of 6 times the square root of 2 for the hypotenuse. So you have a right triangle with a hypotenuse with a length of 6 times the square root of 2. Then you have one leg with a length of 6, another leg with a length of x. So of course, take your x squared plus your 6 squared. You'll set that equal to the length of the hypotenuse squared, which would be 6 times the quantity of 6 times the square root of 2 raised to the 2nd power. This would turn into x squared plus 36 equals 36 times 2, which would have to mean that x squared plus 36 equals 72, which would simplify into x squared equals 36. And we know the positive square root of 36 is 6. So x equals 6. So both of these legs are length of 6. All right. Oh, this is really good. So obviously we have a parallelogram, that's for sure, and it's split into 2 right triangles. Alright, so let's see, this leg here has a length of 24. The hypotenuse has a length of x. This leg here has a length of 7. Of course, we need to solve for x. Well, we know the hypotenuse here of this right triangle has a length of x. This leg has a length of 7. We don't yet know the length of this leg since we're trying to solve for x, but what do we know about parallelograms? That opposite sides are congruent. So this leg here would also have to be 24. So now we can go ahead and solve for x. This would make that hypotenuse x squared equal to 7 squared plus 24 squared, which would have to mean that x squared equals 49 plus whatever 24 squared is. I know what 25 squared is, I just don't know what 24 squared is off the top of my head. It's 576, okay. So that's x squared equals 49 plus 576, which would simplify into x squared equals 625. Well, the positive square root of 625 is 25. So x, the hypotenuse, would have a length of 25. So yes, sometimes you will see other shapes that are split into right triangles. You will have that sometimes. Though it's important that we remember previous theorems and properties as well, because they can help you with what you're doing here in the more advanced stuff. All right. We have right angles here and here. And here. And here. Alright, so a length of 12 here for this leg. The hypotenuse has a length of 15. This leg has a length of x. We actually need to solve for x. Well, I think it's clear now we have a rectangle since we have 4 right angles, right? We got 4 right angles, and a rectangle is a type of parallelogram. So opposite sides of a parallelogram, and by extension a rectangle, are also congruent. So this leg here would have a length of x also. Now we can solve for x. Okay, so you'll take your leg x, raise that to the second power, plus the length of this leg 12, raise that to the second power, set that equal to the length of your hypotenuse, which is 15 raised to the second power. And then this would turn into x squared plus 144 equals 225, which means then that x squared equals 81. And we know the positive square root of 81 is 9. So x is equal to 9. All right, let's see here. Which way does it go this time? Okay, right here. Alright, so we definitely have a quadrilateral here. We have 2 consecutive sides that are congruent, and we have 4 right angles. This makes this a square. And a square is what? A parallelogram. So that means that opposite sides of the square are also congruent. So this leg here would also be 8. Now we can proceed to solve for x. You also could have done the fact that this leg here was 8 by the same reasoning. It really doesn't matter. You could have gone either way. But we want to solve for x, which is the length of the hypotenuse. So we'll take x squared. We'll set that equal to 8 squared plus 8 squared, which means x squared equals 64 plus 64, which means then ultimately that x squared equals 128. So then we only consider, of course, the positive square root. That means x is equal to the square root of 128, which does simplify further because 128 has factors of 64 and 2, which 64 is a perfect square. 2 is not, so we can't do anything with that, but ultimately x would have a length of 8 times the square root of 2. So the diagonal of this square with length x is equal to 8 times the square root of 2. Don't have many more exercises here. All right. let's do about 7 exercises here that are a little bit different than what we've done so far. But it still applies Pythagorean Theorem nonetheless. Absolutely does. I could draw better than that. That's definitely not what I'm trying to illustrate here. That's better. Alright, so this is a right angle here. This has length 6. Each of these have length 8. This time, we are going to find the value of x again, but it's going to be the length of this whole side of the triangle, right? Okay, so what you're going to do then, you have a triangle split into 2 right triangles. So, what you want to do now, of course, let's call this leg, we'll call that B, okay? We'll call that length B. So we'll take B squared plus 6 squared. We'll set that equal to 8 squared because 8's the hypotenuse, which would have to mean that B squared plus 36 equals 64, which would then give you that B squared. So what is, see, so 64 minus 36 is what? It's going to be what? That should be 28 if I'm not mistaken. Yeah, that would be 28. Okay, so B squared is equal to 28. Well, that means B is equal to positive square root of 28. And then B, of course, is equal to the square root of 4 times the square root of 7. So that means the B has to have a length of 2 times the square root of 7. So this leg here for this right triangle would actually have a length of 2 times the square root of 7. Okay? Well, we still want to find the whole length of x, but in both triangles, these are both right triangles. Both of them, you have the hypotenuse congruent and you have a leg congruent. So by the HL theorem, the hypotenuse leg theorem, you can say these two triangles are congruent, which means that this segment here would be congruent to this segment by the fact of CP/CTC. Corresponding parts of congruent triangles are congruent. So now let's find x. X is equal to 2 times the square root of 7 plus 2 times the square root of 7, which would have to mean then that x has a length of 4 times the square root of 7. So your answer would be that x has a length of 4 times the square root of 7. So yes, knowing past theorems is very much going to help you. And postulates and properties and all those things and definitions. 6 more and we're done for the night. Good one. We got actually starting with the trapezoid. But they split them into 2 right triangles. So now you have 2 right triangles here. And let's see what else we have. I think I'm looking at the wrong one. There we go. Alright, each hypotenuse has a length of 13. each of these legs has a length of x, this base here has a length of 11, the whole base here, the entire base has a length of 21. Well, we still need to solve for x, so how in the world are we going to do that? Well, what we have to do now is consider each of these triangles first. Both of them have a congruent hypotenuse with length 13, right? And they both have congruent legs with length x. Therefore, these two right triangles are congruent by the hypotenuse leg theorem. So, in other words, this leg here is congruent to this leg, okay? Well, if we have, let's call this leg B again, right? We'll call this leg B. Now, the whole length here is 21. We split this trapezoid into two right triangles, which would have to mean here now that on the other side of this, you have a quadrilateral here with two right angles and two congruent sides. So if you have two congruent sides and two congruent angles, then you have to therefore have a parallelogram, which would make the length of this part here of this parallelogram 11. So now to find the lengths of these here, you'll end up taking b plus 11, setting that equal to 21, right? Which would mean 2b is equal to 10, which means b has a length of 5. So the lengths of each of these legs here have a length of 5. Now we can proceed to solve for x. Pick your right triangle, it doesn't matter, you'll get the same answer for both. Since we know now that these equal 5, we can now take x squared plus 5 squared. We can set that equal to the length of the hypotenuse squared, which would be 13 squared, which means x squared plus 25 equals 169, which would end up giving you that x squared equals 144. And the positive square root of 144 is 12. So therefore, x has a length of 12. So that wasn't too bad. Five more exercises. I wanted to start out easy, then I wanted to do some of these harder ones because they're necessary. Okay. So this time we're given an upside down trapezoid. Alright, it's going to be split into two right triangles and a quadrilateral. What do they give us for lengths? Okay. Both of the hypotenuses have the same length, which that's good. That's one thing working in its favor. Both of the legs, both of one set of legs have, in fact, the same length. This base here has a length of 10. Now this base here has a length of x. The whole length of that base is x. Of course, we got to solve for x. So, we can already spot that these two right triangles are in fact congruent to each other because of the HL theorem. So that means that this leg up here would have to be congruent to this leg here, okay? And by extension, these angles would be right angles. And of course, you formed a perfect. What you did is you broke this into perfect squares. So, or I should at least say perfect quadrilateral, which would be at least be a rectangle. So now you have 4 right angles here. So we can now. We know that the length of this side here for this quadrilateral would be 10. So we definitely have a rectangle. We want to solve for the whole thing of x. Well, let's call this leg length b first. Let's break this down. So this would break down into b squared plus that length of 12 squared would equal 15 squared. Right? So then you would have b squared plus 144 is equal to 225, which would then end up giving you that b squared equals 81, and the positive square root of 81 is 9. So b equals 9. So now each of these legs of the right triangle have a length of 9. Now finding the length of x is easy. X is simply equal to 9 plus 10 plus 9, right? You take the length of each of these segments, you end up getting 19 plus 9 is 28. So the length of x is equal to 28. So I was able to prove that these two right triangles were congruent, and this here is a rectangle. I used the properties of each and was able to determine that the lengths of both of these legs here were the same, coming up with the lengths of each of these legs being 9, and then you just add the lengths of the segment and you get that x equals 28. Oh, this is a real good one. I don't like how tilted that is. Now here's a fun one. This has length of 5. This has length of x. This has length of 8. The whole side here has a length of 11. We need to solve for x. Oh yes, and these are right angles, by the way. So, how are we going to solve that? Well, remember auxiliary lines. You can draw an auxiliary altitude in this case. Draw yourself an auxiliary altitude, which then would create a right triangle here. And of course, by extension, this would be a right angle, and then this would be a right angle, because that's all that would be left for that quadrilateral. Now we're one step closer to solving for x. Well, what do we know here? We have a rectangle now, right? This is a rectangle since we had the auxiliary altitude formed to make this a right triangle. And then this becomes a rectangle. What do we know about rectangles? That opposite sides are congruent. Of course, ultimately we want to solve for x, but if the whole length is 11 and this length is 5, that means the length of this leg here would have to be 6. Now we can go ahead and solve for x. You can end up taking x squared, set that equal to 6 squared plus 8 squared, which then would give you that x squared equals 36 plus 64, which means x squared equals 100, and the positive square root of 100 is 10. So x has a length of 10. So yes, don't be afraid to use auxiliary lines when and where you need to and split these into separate shapes. That is sometimes necessary. Alright, we just have 3 more and we're done. Another odd shape. This will be another fun one. So we have a right angle here. This length here is 12. This length here is 6. This whole length, the whole length of this segment here is going to be 10. We need to find the length of this here, the x. So what are we going to do? Well, remember auxiliary lines. If you use auxiliary lines, you can draw an altitude from this side to this side and form yourself yet another right triangle. You can totally do that. So, how are we going to solve for x then? Well, let's look at our rectangle that we formed here, because we've just now formed a rectangle since by extension this angle is a right angle, which by process of elimination would leave this one to be a right angle. Opposite sides are congruent. So this leg here would have length x, which means this side of the rectangle would have to have a length of 6. So if the whole length is 10, 10 minus 6 means the length of this leg is 4. Now all you have to do is take your x squared plus 4 squared and then set that equal to 12 squared, which would then give you that x squared plus 16 equals 144, which means that x squared equals 128. So x equals the square root of 128 and only the positive square root of it, which then means that x would be equal to the square root of 64 times the square root of 2, which then has to mean that x would equal 8 times the square root of 2. So the length of x would be equal to 8 times the square root of 2. Should just be 2 more. We're almost done with this, folks. Let's establish here that this is a right angle. That might help. Actually, they didn't tell you that. Never mind. I'm looking at the wrong one. Sorry, folks. But what it does tell you is it draws an altitude from here to here. Alright, so we got the altitude drawn. You have a right angle here, which in turn would give you a right angle here also. What do we have for lengths? We have 10, 6, we have 15, and then we have x. Well, this might look like 2 right triangles that you could combine into one, or one big right triangle split into 2, but they don't tell you that this angle is a right angle. So we don't officially know that. But I think this time we'll call the length of this leg A. Nonetheless, we have two right triangles, right? Let's start out by finding A before we solve for x, what we really came for. So you'll take your A squared plus your 6 squared, set that equal to 10 squared, which would then give you A squared plus 36 equal to 100, which would then give you that A squared equals 64, and the positive square root of 64 is 8. So the length of this leg here, which will actually cover both right triangles, is equal to 8. Now that we have the length of this leg here, which covers both right triangles, we can proceed to finding x. So take your x squared, set that equal to your 8 squared plus 15 squared, which would then have to mean that x squared equals 64 plus 225, which means x squared equals 289, while the positive square root of 289 is 17. So the length of x would in fact be 17 in this case. One more exercise, we're done with this lesson. Very interesting, yes. Very interesting indeed. So it starts out here. You have an angle bisector. You have an angle bisector of this triangle going to the opposite side. Well, they tell you here that this is 45 degrees and this is also 45 degrees. So that is a true angle bisector. You have a length of 3. For this, you have a length of 4 here, and then only this segment has a length of x. Well, you need to find the length of just x. So, how are we going to proceed with that? Well, what I would do is call the length of this whole side C. Call the length of that whole side C, because if you have a 45 and 45 degree angle, what do you have? Really, it's a 90 degree angle if you combine this into one big right triangle. So now you can solve for C. So what that's going to look like is you're going to take 3 squared plus 4 squared, set that equal to your C squared, which would then make C squared equal to 9 plus 16, which would then make C squared equal to 25. Well, we know for a fact that the positive square root of 25 is just 5. So now the whole length of this side is equal to 5. Right? So now, of course, we just got to solve for the x. Well, here's where it gets tricky, and it's going to bring in a property from yesterday. This is actually going to bring in a property that we have here from yesterday. If the altitude is drawn to the hypotenuse of a right triangle, so remember this, if the altitude is drawn to the hypotenuse of a right triangle, the leg is the geometric mean between the length of the whole hypotenuse and the segment of the hypotenuse which it touches. So yesterday's coming back a bit. So this leg 3 would be your denominator of the first ratio. And of course you'd have 5 being the length of your whole hypotenuse. So we're taking the length of the whole hypotenuse to this leg. Then you'll have 3 in the numerator of your second ratio to the segment of the hypotenuse it touches, which would be x. Now all we have to do is cross multiply. You would end up getting 5x equals 9, which means x equals 9 over 5. Well, what is 9 over 5? That's 1 4/5, which means x has to equal 1.8. So x, therefore, has a length of 1.8. So this started out trying to solve the length for the whole right triangle, and then we brought in yesterday's lesson with that corollary that if the altitude is drawn in a right triangle from the right angle to the hypotenuse, that each leg is the geometric mean between the length of the whole hypotenuse and the segment of the hypotenuse it touches. So x is equal to 1.8. So it's important to keep up with what we've been talking about. But that's it for this lesson. Next lesson is going to be the converse of the Pythagorean Theorem, which actually has 3 parts to it. And we'll go over that for the next lesson. But I hope everyone has a great night. Take care.